So, not a whole lot of PR updates in the last 2 weeks. Two new ones that I saw. One is from me that's really small. Just, I guess there's a lot of text in the description, but not actually much in the PR itself. Uh, the only real thing of consequence in this is changing the O-node map from unordered map to standard map, and that's a little controversial, I think. I'm not sure if we really want to do it. That's why it's RFC. So um, the reasoning for this is right now it appears that we see significant collisions with unordered map due to the way that the hashing works. So standard map does not suffer from that, or we could do a separate like owner map specialization of standard hash, which would maybe be also a dramatic improvement probably. But we can talk about that more later. Anyway, that's what that changes. Let's see, next PR, new one is PR for RGW. I didn't actually look at what it does, but the complaint here is that we don't actually do any kind of OSD compression after RGW compression, which I'm not sure. Maybe that's what what he wants to do. I don't know. It seems like if you're already compressing, maybe you don't want to recompress, but I don't know. Anyway, that's a new PR. Someone's looking at it. 3 closed PRs in the last 2 weeks. This one for scattering alien store threads onto specified CPU cores. I talked to Kifu about that. I think we thought maybe it should just be the first part of this PR, but I think Kifu merged it, so maybe he was happy with the second part too in the end. This is just it's a little more advanced than just basically specifying which cores the alien store threads should land on. But in any event, that's kind of one of the major things that this PR does, which is really important since before all alien store threads landed on the second to last core on the system, no matter what Crimson process they came from or anything. So that's a good fix. Bluefest buffered IO true merged, or basically switching that back again. This was pretty much necessary. We did pretty extensive work trying to dig into the behavior here, and both users were seeing that this was causing huge issues when we had buffered IO disabled, and we were seeing RocksDB doing a lot of reads on the disk in other situations. So in the end, we turned it back on. Maybe not permanently. We'll just kind of have to see how things go. There's a chance that we may hit a bug that was reported where the kernel starts swapping out stuff really aggressively, presumably to fulfill cache or fulfill memory needs. That was causing huge performance issues under certain RGW workloads. But that seems to be a less bad situation than what we're seeing now. So anyway, that's what it is. Oh, and then in the past 2 weeks, my dynamic pen length PR for refill append space merged. I think we took care of all of the alignment concerns that we had with this, and it did continue to show performance gains, especially in a couple of new tests that we added that tried to do a better job of really kind of isolating behavior of appends and tcmalloc when you have like a lot of reserved memory already, or a lot of allocated memory. So I think that's good. I think that will be generally a good improvement for us in a lot of areas that aren't real visible. But we'll see. Let's see. Updated. The Gabby's remove allocations from RocksDB PR. It looks like maybe there's just some bugs that need to be worked out in that, but otherwise, he was mentioning me yesterday. The performance improvements look really good, and we're seeing not quite as good efficiency gains, but still efficiency gains nonetheless with it. So, still really excited about that PR. Let's see. Oh, my OMAP bench test that got updated. So that's it now lets you specify the number of unique hashes to use in each object T to better simulate what happens when you distribute objects over PGs. So if you're interested, take a look at that. And then just more testing on this concurrency PR for Ceph volume that lets you do things parallel. I don't really know if that is merging soon or not, but it's going through testing, so good. And that's it for updated stuff. Did I miss anything, guys? All right. So I don't know that I'm going to spend a ton of time going over it unless people really want to, but I did want to talk about some of the work I've been doing looking into the BlueFS buffered I/O and OMAP performance issues that have come up. Well, has been going on for a while now, I guess. So this kind of all started when we started getting reports from users that they were seeing really, really bad performance impact for things like snap trimming when we switched buffered I/O off. And Adam did investigation, and I did investigation. Other people have done investigation, and some of this seems to be related to RuxDB's internal behavior with prefetching and the way the cache works and some other things. Some of it may be related to our RuxDB BlueFS layer, and kind of Adam fixed a bug there where we weren't properly reporting the behavior or what we were doing back to RuxDB. But then some of it also is inside BlueFS itself, or sorry, BlueStore itself. What I saw is that there were kind of like 3 separate issues that I was seeing when trying to benchmark the OMAP, OMAP behavior in BlueStore. The first is that, well, I'll start out on a good note. The first is that BlueStore actually can be faster than FileStore and MemStore in kind of ideal situations. It's not all bad. It's when everything is in cache and when you're doing buffered I/O specifically, and just everything is happy, it's faster pretty much in everything than FileStore. So yes, that's good. But there's a lot of ways for our implementation in BlueStore to slow down. The first that I saw was that we have hash collisions by using unordered map with the way that HObject-T is hashed. We allow the caller to set the hash value themselves. And when we do that, we typically use some, I forget exactly, some in Crush we use the PG seed, the placement group seed, at least partially in that hash. Josh, do you remember, was it directly the seed, or was it some variation on it?
I think it might have been the seed, but with a mask of some bit. Blade. I forget exactly what it was.
Yeah. In any event, it's not unique, right? Per object.
Right.
We end up with a lot of collisions. And potentially anyone that creates HObject-T could set it to anything they want. So it's very difficult to contain it. Like to say, we know it's always going to be good because we don't. It may or may not be good. Maybe normally it's okay. That's kind of where we're at now, I think. So we can fix this in a couple of ways. We can switch to standard map, which potentially could slow down if you have lots of stuff in the onode map. But Adam, I think you were saying that you didn't think that we would, given the code we have right now, that shouldn't grow too large, right?
Correct. My reasoning is that there is limited amount of nodes that we can have active in memory. And even if we had like very large OSD, then I would assume that we will try to increase the number of shards. So that shouldn't be so bad.
Okay, yeah.
What numbers are we talking about?
Sorry, Ronan, what was that?
What are the ballpark numbers? What sizes are we talking about?
The tests that I've been doing so far have been just with 100,000 objects, which is pretty small, and 100 OMAP entries per object. Potentially, that could be higher, but the onode map itself should be smaller per shard, right?
And just the active.
I mean, I guess the question is, how many onodes can we keep in cache? I believe, well, it depends on how fragmented things are, right? And how big the object is, because the onode size isn't static.
Well, in my tests for 4 gigabytes OSD memory target, I was having like 40,000 OSDs divided by 32 cache shards.
40,000 onodes?
40,000 onodes.
Okay.
Plus or minus.
Sure. So, I mean, it could maybe, you could construct a case, right, where you have very few shards and you have lots of memory, and you could maybe in that case see standard map be slower than unordered map. But we're not talking about 30 million entries in one individual map. At least I don't think we are.
But even if map grows significantly, it will still be logarithmic cost to search through it. But with instance collision on unordered map, we are hitting much worse case.
Yes, absolutely. Linear, right? It's a linear search.
Yep.
But if we use a better hashing function, like upscale hash, should it be that hard to just switch the hash?
Yes, so that's the other option, right, Ronan, is that we could do a different specialization of standard hash only for the onode map.
Is it a specialization? You can always specify the hash function as part of the definition of the container.
Yeah, exactly, right? So we could make a custom one just for the onode map that doesn't have collisions, and then just modify the mempool templates a little bit so that we can, make this all nice and clean and orderly, right?
I think that's a better target, better path than going to standard map.
Possibly. There's another document I have where I started looking at a variety of different data structures that we could use for this. I didn't work my way through all of the tests, although in some of the other tabs you'll be able to see them. Go looking. You might have already seen this, Ronan, but I'll supply it in the chat window anyway. Here. So Ronan, I might agree with you. The standard map change is very, very simple. It's really straightforward from our perspective. The behavior isn't simple, but the code change is very simple. We could do the other route, and it's a little bit more work, and we just have to make sure the hash function makes sense. One thing that is a little gross about that, though, right, is that if HObject-T changes behind our backs, now we have to make sure that we update that specialization of standard hash for the onode map specifically, or we could end up back in the same place where we have collisions again, right?
That's what I understand. If the hash function we choose is a good one, I don't see a change that would ruin it.
Sorry, what was that, Ronan? I
didn't understand your last comment. If you are selecting a good hash function, it should be okay. Whatever we do even if we are doing some minor modifications to the underlying.
Well, when we do that specialization for the onode map, right, we're going to reach inside GHObject-T, HObject-T, Object-T, all the way back to stuff like the name of the object to be able to make the hash work well, right?
Yes, but we can build on the at least Upsell, I think, had some automatic with quotes handling of structures, etc., for creating a combined hash. I have to look at it again, but it shouldn't be terribly hard to create a key like a hash like this. And even if something is changed, it simply will break the compilation. It won't probably. It shouldn't be something that affects performance without breaking the compilation. Nothing changes underneath.
That if you were to do something like change the way that we don't even have this right now really in any kind of explicit way, but if you were to change Object-T or HObject-T, for instance, in a way that made it so that the uniqueness of each object was different based on different criteria, then your hash function might not break from a compilation standpoint, but it could introduce collisions, right?
Okay, yeah, but that's pretty long shot. And I assume we can add we can try to, it might be hard, but we can try to add some checks, compilation time checks for the amount of unique randomness in the various parts or the sizes of the various.
Yeah, I mean, I'm not tied to standard map by any means. I mean, it's the simplest thing we can do. But I'm open to making new specialization of unordered map. That was actually, frankly, why I labeled this RFC, because I suspect that there are differences of opinion on this.
I have a question regarding measuring unordered map collision. How can we do that?
I don't know. I mean, I did it implicitly by looking at what was happening with the wall clock profiler.
Okay. Because
I don't have any explicit way to do it.
I've done this once by hacking a standard library that I compiled with that, but that that wasn't very reasonable.
Yeah.
And if we wanted to provide our own hash and look at it seriously, then it stands to reason that we should have some measure how our hash is performing.
Yeah. One word of caution here. One of the things I took from the presentation I mentioned last week from Google, one of the things they were saying is that every time they looked at the code on their site that tried to do definition of hash code and load how's it called, load factor for the map, the code was wrong. It's not easy to get it right. So what they did, their solution was to create a hash function that should be pretty good always and not allow tweaking of the load factor. That was their solutions in their map, so you wouldn't ruin it. I'm not sure we should go any other way. Not sure we should repeat mistakes. Already.
So Adam, I don't have a way to actually measure collisions that are happening at runtime, but I did add to the benchmark just a quick test looking for the uniqueness of the HObject-T hash given the GH-Object-T hash given the hash value that's specified in HObject-T, which is just a 1-to-1 mapping, right? It's however unique HObject-T's hash value is how unique we see the actual current hash specialization for GH-Object-T. But we could easily do that for a specialization, right? We could our own for ONODE map. We could measure how unique stuff is.
Can we, without knowing how many buckets are currently in unordered map?
Yeah, you can count the number of buckets. It's part of the data you know about unordered map.
Oh, okay.
I didn't write it, code, but here is 1 second. I put it somewhere.
I mean, Ronan, it's sort of different though, right? I mean, it's a good measurement, but it doesn't necessarily tell you like how distributed those collisions are or how concentrated they are.
But the total number is a good enough data, isn't it?
Yeah, I mean, like I said, this is a good metric. This is kind of what I already do with looking at the hashes. Sort of, I just look at the count of unique things by throwing in another hash. But like with hashes, right? The interesting thing is that sometimes you can have collisions that follow certain patterns, right? Maybe you typically don't see them, but maybe you really see them in some particular circumstance.
Okay, you can have you can add to if you are looking at the bucket size, you can add, for example, standard deviation.
Sure. Like, is there any correlation between certain input values, right?
Go over a large part of the sample size or really in a test and see what is the distribution characteristics of the bucket size.
Well, so like all of this is is good. To be honest, I don't think it's really going to matter that much if we have an unordered map with a different specialization or a standard map. at least given the amount of O nodes that it sounds like we're talking about per shard. If we had a lot more, I'd say definitely go with the unordered map with the specialization. As it is, I mean, as long as we avoid collisions, I think that was the thing that I noticed the most, is that especially when you have very few unique hashes. So I think the correlation would be very few PGs. If you have a small number of PGs, that it can get kind of bad. But there's lots of ways we can solve this. So I don't really care. Whatever people want to do. Adam, I mean, Ronan, it sounds like you're pretty in favor of the doing the hash specialization. Adam, do you care much? Do you still think like standard map would be?
Well, I prefer having unordered map with a good hash, but I'm just challenging my ability to devise such hash. If we have someone who can do a good hash, I'm perfectly fine with that.
You can try to help with installing upset and see what they come up with. But probably need help with the environment, how to test it. In our case.
I think we have enough fields between HObject-T and Object-T, and GHObject-T, I guess, that we should be able to pretty easily, uniquely identify each object. There's a lot of string comparisons that are necessary, but it can be done.
So next week I send you another. I try to understand exactly how to test what stream I can use and what test to run that you use to see the numbers.
Yeah, sure. If you look, I put the new version of the code in PR, the one that I've been testing. Basically, it just cleaned up a little bit here. And I'll paste in the chat window a command you can use to run it. Give me 1 second. I can provide that. So this command is actually running it inside with cgexec in a C group, but you can remove any of that stuff that. So this is just running it with debug bluestore 5, which actually I'm not even looking at the moment, since I'm grepping all that stuff out. But otherwise, hopefully fairly self-explanatory.
Okay, next week after the Passover 1 day vacation,
Okay.
I will take a look at it and try to see if I can work and run this.
Okay, that'd be great. I'd be very curious to see if you see anything different. In the benchmark itself, I tried to make most of the things that you can tweak and change right at the beginning of the function. So you can modify it fairly easily. Okay, so we got through one of the 3 things that I saw so far. That was related to the data structure. The next thing is that we definitely see effects both for getting objects with OMAP-get and iteration due to buffered I/O and direct I/O. Buffered I/O is faster generally, and also especially with iteration, you are much, much better if you can store all of the OMAP data in the if you can store probably both OMAP data and ONodes in the caches, the respective caches. So OMAP data in the RocksDB block cache and ONode data in the BlueStore ONode cache. It's substantial how much of an improvement that provides. Having said that, there was also an effect that I saw both for these OMAP get and iteration, and especially insanely so for remove when doing operations in a specific order. Originally, when I first wrote this benchmark, I was just looping over an array that was sorted by object name. So object 1, object 2, object 3, whatever. I actually did not realize when I started this that that's not the ordering that we use for objects. We actually do ordering more based on PG than strictly based on the name. And this, when looping over objects in this way, it looks like, I haven't verified this, but it looks like we probably are scattering I/O across many different SST files in RocksDB. And it's just really nasty, right? We're going all over the place. When we do things in order using standard sort to get we implement everything right in GHObject and the other HObject and all these other things to do our own sorting or our own ordering. So when we use standard sort to sort that array, then performance for a lot of things improves, and remove is insane. I mean, for 16 gigabyte memory buffered I/O, it's like 160 times faster for removing ONode data. It's just crazy, right? It's a huge improvement. So this might not matter. If we typically are doing things, have our data structures, when we store HObject sorted, we can probably do things, operations against them quickly. But if we're not sorting them, if we're just storing them in some random order or in an order that's different than what's expected, we could be extremely slow. So probably one thing we need to do is go through and actually audit all of these places where we store GHObject and make sure that we're not doing things in a suboptimal way. One thing I forgot to mention is that Adam and I have been talking a lot about the possibility that when we do iteration, if we don't have enough memory to store all OMAP data in block cache, and this test was designed to in the 4 gig case, there's enough data, enough OMAP data that it won't all fit in memory until you increase the OSD memory target. So in this case, it appears that we are very rarely or potentially never actually doing reads from cache, because when you start an iteration, by the time that you've finished it, the beginning has already moved out of cache. So like if you're doing this like a repeated iteration over and over and over again of the same data, potentially when you start the new one, you've already lost the cache data for the beginning of that next iteration, which means you reload it. And as you reload it, you push out things further along so that you never catch up and you never re-hit cache again. This is what we suspect is going on, but we haven't proved it. So that's basically where we're at. I don't know with some of these things how to fix it without kind of big changes, right? Like one of the reasons why the page cache is better is that if we don't have enough memory in our caches to store all like OMAP data during iteration, potentially if you've got a big page cache and not all OSDs are doing iteration at the same time, some of them might be able to temporarily gain lots of memory, do things, while others need less. If we had some ability for the OSDs to be able to share some pool of common memory that they can use when needed, kind of like a page cache, then we might see a lot of the same benefit that we see here. But it seems like yes.
I have a question here. When you start doing iteration, don't we know what is the total size of objects, or the number of objects that we need, and we can calculate from the beginning whether it's going to fit into the cache or not, and do different things based on this?
Well, so this is for OMAP. It's the block cache, right? So this is iteration that we're getting like a RocksDB iterator. So we might be able to solve it there. We have our own version of the RocksDB LRU cache, but I don't know. I don't know how difficult that would be to.
The question was the question whether we could predict when we start iteration whether it's going to fill up the cache or not. First of all, if we have this information, then there are things that we can do. There are various things that we could add into the cache evocation process in order to improve it. But the question whether we have the prediction at the beginning that we know that we started at the start operation that is going to misuse the cache. If we know this, then we may have some things that we can do.
So it'd be way easier if we actually just directly had an O-node or OMAP cache, right? And we knew what the size of the key and the value were, and that's what we cached. Then we could really easily say, okay, we know how many entries, how many objects there are. And, well, I guess I don't know if we know exactly how many entries there are per object. If you had one big object that had 100,000 OMAP entries on it or something, then you could maybe find out and do it. But I don't see how we would do that with a block cache.
Okay. If we have this info, we could have. There are policies that we could apply, but if we don't, I don't know how it is built, but it's something that maybe the direction to pursue at the beginning. Try to have reasonable prediction about the size of what we're going to read and whether this is going to fit into the cache or not.
Frankly, right now, I don't even trust that the block cache in RocksDB is working the way we expect it to in general, because we're like in some situations, like for OMAP get, with buffered versus direct IO, even when we have a ton of memory for it, we still see get performance behaving like there's no cache at all, or very little cache.
Yeah.
So I don't know. I mean, maybe we can do something clever inside RocksDB, but I'm not super hopeful. We'll see.
Well, my line of thinking would be to first exactly examine behavior of our block cache implementation, and then from that infer what we can and what we cannot do with that.
Yeah. Probably, Adam, the first thing there would be to look at your statistics that you've got so that we can actually determine even if the block cache is properly being used.
Yes, along with what is the distribution of age of elements in that cache and its reuse. That all that could be extracted from this.
Yeah. Are you using the age binning to that would be one way that we can get like a histogram of the ages in the cache?
No, actually, I just made a timer to take a time snapshot when element was last referenced from RocksDB, and then it was sorted by order, and from there you could list elements that were very old, and you could see elements that were hot. That was some approach to
okay.
split of age in elements.
Okay, interesting. Well, yeah. So maybe that is the next step, is to actually take a look and dive deeper into RocksDB's block cache and figure out what's going on. Any other comments or questions on this stuff, guys? All right. Well, then the other thing this week that I thought maybe would be good to bring up, since there's actually quite a bit of discussion going on with it, is Igor and Adam have been investigating and fixing issues with the BlueStore caches, specifically around trimming and splitting. But the bugs don't end there necessarily. That's the most likely way that we hit them. So this is the way that the locking works and the complications around it, given when we try to split caches and do other things. Igor or Adam, you guys are both looking a lot more deeply at ways to like modify this. Would one of you want to talk about some of your ideas?
I'm not really ready yet to have any.
Okay.
I do not have any more ideas than what I learned from Igor, so it's only Igor that might decide that if you want to share them now.
Well, I have pretty similar feelings as Adam, I'm afraid. I need to take his ideas maybe in thought to proceed. I suggest to bypass this discussion for today.
Sure.
Yeah, the only thing I'm intent to do is actually to approach to some formal proof of our locking, merging of atomic increment of reference counter and locking, and find some model, maybe some tool that could prove that such design is correct, or find a path that breaks it, so I could improve it and finally get it done finally.
Sure. Yeah, I think I'll just say the same comments I said earlier, which is that I think we should be willing to give up a little bit of performance if it makes the locking simpler. If we can do things like if we think that split cache really happens rarely, and it would make things simpler to make split cache work harder, either by draining the caches or whatever. I would be very much in favor of that, I think, personally. That's my take.
All right. Well, just to note, my idea is to avoid any data movement during split cache. So if we attach a node to a cache shard permanently, then we don't need this stuff, split cache. And potentially this makes things easier, despite just one case when we need to enumerate all the nodes for a specific collection. But as far as I can see, it happens on collection removal only. So maybe it's a way to go. But this actually moves us to prior discussion about effective node map or a noded map, since we would need a node map per cache shard, not per collection, and hence we will have more entries in each not map instance. But well, since they depend the lookup time should be in logarithmic. So it grows in logarithmic. I'll forget the word. So it's not well. In other words, it's not that bad to have much more entries if our data structures are good enough. Just thoughts for now. Because well, I think actually I don't like these movements between different containers and adjusting parent collection and things like that in the split cache, and hence we need to protect it properly. It looks not very elegant, let's say.
Yeah. All of this stuff has been kind of a thorn in our side. It's complex, hard to get right. If you want to pursue bigger changes, which it sounds like maybe you're kind of thinking, it is not necessarily a bad idea.
Yeah, so current design is hard to maintain. Indeed.
Okay. Well, maybe we'll talk more about it in the future then. That's all I've got, guys. Anyone have anything they want to bring up?
Well, maybe we can discuss a bit different approach, or rather absolutely different approach, which is what we have currently in Nautilus. And in fact, it has nothing about split cache, but it's more about pinning. And in fact, we do not have. Well, we still have pinned objects in Nautilus, and they are not cache shard. They remain there despite their state, their pinned or unpinned state. But instead, during cache streaming, we just bypass them and preserve the last position when they ended. I mean, all the pinned entries, and then on the next iterations, just start over from that position rather than from the end of the list. And in that case, we don't need all these complexities around a node get and put. They just increment the reference count, and that's all.
It was problematic. Go ahead. Sorry, go ahead, Igor.
Well, I just want to add to that. Hence, we don't need lock acquisition in these get put methods, which actually are hardly to control since they occur under from different code locations under locks or without additional locks and things like that. So simple put get it's pretty nice to have that simple put get, and on the other hand, we don't have much performance impact in in trim function, since we just bypass these pinned entries which are at the bottom of the list as we cache the previous position. So I don't expect much overhead here. And in fact, that's what we currently have in Nautilus with my recent changes. We haven't backported all this pinning stuff we are currently discussing to Nautilus, but we faced an issue with high memory usage under some scenarios when tons of pinned entries at the bottom of the at the bottom of the node cache prevented from cache streaming, and well, for some reasons these pinned entries are staying there for ages, and hence no trimming occurred, and we need that sort of workaround. But in fact, it doesn't look that ugly, so maybe we should use it as a regular solution.
Yeah, I agree with Igor that first when his solution appeared in Nautilus, I didn't really like it, but then I see that it has its cost, but the solution would be to really simplify a lot around O-Nodes. So definitely we should keep that path open.
Before doing that thing I did originally back for like having a separate pin list, I had a different set of things I was doing that made it faster. I don't know how much your changes, Igor, look like that, but maybe some combination of what you have, and then if mine are any different than what you did, maybe that would be enough.
Well, in fact, I don't have any additional lists for that. I just preserve the pinned entries in the list and simply try to bypass them effectively when I need to find everything to trim.
So, okay, you're storing the pinned entries in a separate list? Is that what you said?
No. They are left in the same list.
Oh, in the same list,
but it's easier since you don't need to move them back and forth.
Yes, definitely.
Yeah, and in this case, we have just, it looks like we have just a single issue, how to effectively bypass these pinned entries during the trimming.
Yes.
So, well, my solution is just to keep the position when we see the first non-pinned entry and start the trimming from that position on the next iteration.
Yeah.
Looks pretty straightforward and trivial.
And then do you round robin back to the original place?
You mean to the end of the list? Yeah. If trim was successful, then it starts over from the beginning and something like that. So yeah, it definitely can. It's not a round robin scenario, but it resets this last position under some scenarios in some cases.
What do you do in the case where you don't actually successfully trim because there's so many pinned entries that you never got to the you went through and you never successfully trimmed everything you wanted to?
Well, if I don't find any entries to trim at this specific iteration, I just preserve the position where I stopped searching from, where I stopped searching, and on the next iteration I start from this position to the fourth, and sooner or later I'll find entries to trim unless everything in the list is pinned.
Yeah, that was the thing that we ran into. Like, how do you decide when to stop? Is the question, right?
To stop what?
Trim, right? You've marked a position that you start at, so you start there, and then when you stop.
We had a cap to trim, say 30 entries per iteration. So on each iteration I either trim that amount of entries or bypass that amount of pinned entries, or a mixture of cases. So each iteration just moves the pointer, and sooner or later it will find entries to trim. And I don't remember exact details, but if you are smart enough, you can proceed with trimming from the last position again and again. But the interesting thing about this LRU list is that there are no random insertion or no insertion to the end of the list. So it looks safe to I don't know, we need to, if some entries become unpinned, we should reset. Okay, I need to double check the details. So definitely it resets the pointer at some cases. And well, we might probably introduce some additional logic there, but it doesn't look very complicated. I believe it's more trivial than all this locking.
I agree. I remember before we did this whole separate pin list thing, which ended up being a bad idea. I think I had some like smaller changes that were I think kind of like what you're doing, right? Where you store the position, and then there were some other things I had done. I'll see if I can dig it out and figure out what it was, but I remember it helping. It wasn't perfect, right? Like the problem you have is that you're going to do the iteration at some point, right? You're even if you leave off and stay, at your last position and don't start over at the beginning again, it helps. But you still, if you never have enough entries that you can clear, you're going to walk through tons of stuff, either this iteration or the next iteration, and you're going to just keep going over and over and over again, right?
Yeah, but maybe that's actually.
Mark, I understood it differently. Igor, please check if my understanding is correctly. Igor's algorithm is in each trim event is walking from bottom of the LRU list, but only for a fixed amount of entries. So if you have 1,000 entries in your 1,000 pinned entries on the bottom of your list, and you started iterating from the bottom and have 100 in one trim event, then you would need to have 10 trim events to actually get to the elements that you really want to trim. But once you get there, you will really start trimming, and you could trim as much as you could. So you will not be bothered by very many iteration in each separate trim action, but your delay that you actually trim something could be bigger. In this case, 10 trim events before you actually trim something. Is that correct, Igor?
Yeah, something like that. But again, I don't remember the exact details of the current implementation, but something like that. Yeah. I don't remember when I reset this current position to back to the bottom. Under what circumstances?
Adam, the way I remember the original code from Nautilus before we started and all this stuff worked is that we would trim. We try to trim a certain number of entries per trim, right? We do that, but if there are pinned entries, we just skip over them. So we would always keep searching until we could trim off whatever it was, right? But we'd skip those pinned entries. Igor's thing improves it, I agree 100%, by not making it so we iterate over all of those trimmed entries at the end, or pinned entries at the end, over and over and over again for every trim event, right? So that is a big improvement.
Well, the general idea was that previous implementation didn't iterate over all pinned entries. It stopped after, say, 30 entries. So if you have 30 entries permanently pinned at the bottom of the list, you would never get cache trimmed.
Okay. At some point, I thought we also made it so that we just changed that so we'd always try to trim 30 entries, but we'd skip over pinned entries so that it was then a different problem of trimming was so expensive because you were like iterating over things over and over and over again.
Yeah, so if you have a bunch of permanently trimmed entries, well, if you start over on each iteration and bypass all of them, it's expensive. If you stop after certain amount of such entries, then you might have cache. You might get cache growing constantly if these entries are permanently pinned.
Yep.
So we need something between these cases, and that's what I tried to achieve with preserving the previous position and then trying to not starting to trim from the bottom each time, but trying to go ahead on each iteration until I expect. Well, as far as I remember, until I find something available for trimming, I move the pointer. But once I find once I manage to trim something, then I reset the pointer and then starting over from the beginning. At least this provides cache trimming. Well, at least it avoids the permanent trimming.
I wonder a little bit if instead of like round robining over it, if you did some kind of like lopsided bisection sort of, right? Where you know that most of the pinned entries are going to be at the end, but not all of them. But maybe you don't want to actually round robin back over to those at the end. Maybe it's like you want to just kind of try to grab things sort of towards the middle, and if you're successful, then like maybe a little farther back, or if you're not, then go up more?
Well, just got another idea. Maybe similar to your ones to some degree. Actually, what we have with these pinned entries is that when they become unpinned, they go to the beginning of the LRU. So maybe we can move them exactly once we found them in the bottom. So during trimming, we go from the bottom. If we find the trimmed entry, we move it to the top, and hence we wouldn't meet it on the next iteration at the bottom, and highly likely it will go up to the list anyway once it gets unpinned. The only issue with this case is the scenario when we want to remove this node shortly after the unpinning. So if we unpin, say, non-existent node, then having it on the top of the list will delay its actual removal. But again, we can probably think about more effective scenario. But again, the general idea is that in regular scenario, pinned entries go to the top of the list once they are unpinned.
Yeah,
but
I think you're right.
This happens on unpinning, but actually we can perform that on trimming. When trimming finds such a node, we can move it to the top.
Yep, I think you're right, Igor. That sounds really elegant. I think that's a good solution.
I like that. We really could insert any node that we delete, is false, just above your pointer for trimming. So next trim will visit it. And then hence we will move actual deletion of nodes that no longer exist to trimming operation. That will be consistent with getting rid of trimmed entries.
Yeah, makes sense. So okay, I'll try to clean up this idea and maybe make a PR for RFC, and let's try this approach. Check if any issues are there.
Cool. All right. We are over time, guys. Anything else?